All right, section 5.2. Let's start factoring trinomials. So I will tell you, this section is usually a lot of fun for people. It usually goes well. And let's dive in. So here's the idea. In the last chapter, we learned to multiply things like this out. So I have x plus 5 times x minus 3. And you can see I did x times x and got x squared, x times minus 3, 5 times x, and 5 times negative 3. And then I combined to get my trinomial at the end. So now what's going to happen is we're starting with trinomials, like this thing down at the bottom, and we're going to try and work it backwards to find the original multiplication problem. Okay, this is what most people think of when they think of factoring. It's this stuff right here. And so there are some really good uses for that, and they'll come later in this chapter, so you'll just have to hang on to those. All right, so we have a basic process that we're going to go through over here on the right-hand side. And we're going to see how this works. And it's actually really, really slick. The important thing here is in this section, we're dealing with trinomials that just have x squared at the beginning. Okay, so we're looking at trinomials of the form x squared plus bx plus c, where b and c are just numbers. So what we're going to be looking for to make this work is we need a pair. That's why I wrote find a pair. We're going to find a pair that does two things. It needs to multiply to equal that number at the end, what I have as c here, and then it needs to add up to the b in the middle. And so let's take a look at an example. We'll see how this works, and then guess what? There's even a shortcut, which is awesome. So let's do it. Okay, so here's our first example. I'm going to use this one to explain what's going on, and then I'll tell you the shortcut, and we'll do one or two more examples with just using the shortcut, which is so nice. So importantly, when we do get to the shortcut, it only works if this is just x squared. If we put any number in front of it, it's not going to work. Okay, so that's super important, something we really need to pay attention to. And we'll see that a lot more in section 3. So here's what I did. I said, okay, if you remember what I had on the last board, we need a pair of numbers that multiplies to be that number at the end. So in this case, multiplies to be 35. And adds up to the number in the middle, the 12. Okay, notice I don't care about the x. I just want the number. I need a pair that does this. So one way you can do this, and sometimes it'll just jump right out at you, and you go, hey, it's got to be 5 and 7. Right? 5 times 7 makes 35. 5 plus 7 makes 12. Sometimes they're easy to see, sometimes they're not. I like to recommend write out as many pairs as you can that make the multiplication work. Okay? I have pairs here that multiply to be 35. That's a really good place to start. And from that, then you can try and put it together in a way to get the addition to work. All right, so anyway, I had my pairs, 1 times 35 and 5 times 7. The pair that works here, the pair that actually adds up to 12 is 5 and 7. So coming back, what's happening then is we're splitting up our middle term. So we had 12x, and I'm going to use the 5 and the 7 to rewrite it with a 5x and a 7x. Okay, and then you can see I've got factoring by grouping that I did, and we'll talk about that, but I took my 12x and I split it into 5x and 7x, which is legal because guess what? 5 and 7 is 12. Okay, so all we did was rename that 12. So then I did factoring by grouping. I put my parentheses in, said, hey, my common factor in the first set is x, so I divided by that. The x went in front. When we divided, we got x plus 5. The common factor in the second set was 7. I divided by 7. It goes in front. Left me with x plus 5. Then there's that set of parentheses that we saw in the last section. It's a common factor, so I divided by it. Don't forget to put it out front. And if you do your division, those parentheses drop out. We get x plus 7. And so we end up with this wonderful little multiplication problem. That's actually the answer. You don't multiply back out, you just stop right there. But I want you to notice something. We got x plus 5 and x plus 7. What did we have over here for our pair? We had 5 and 7. And it turns out, if you have a problem that starts with just x squared, or whatever variable you want squared, it could be y or p or q, whatever, it will always factor like that. Once you find the pair, since it was a positive 5, we have x plus 5. Since it was a positive 7, we have x plus 7. If one or both of those were negative, we would just use minus signs. And maybe we'll see one of those here in just a second. Okay, here's our first example using the shortcut. So this will be fun. Here's my problem. X squared plus 5x minus 24. Go ahead and ignore the answer for just a minute. All right, so here's what I did. I need my pair. We always want to find that pair. It needs to multiply to be negative 24 and add up to the 5 in the middle. Okay, again, I don't need the x. I'm just looking at negative 24 and 5. So I need to find two numbers that do that multiplying and adding. Here I have a list of all the pairs of nice numbers that multiply to be 24. So I start by ignoring any negative signs, in this case the negative on the 24. So I just want what multiplies to be 24. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, once I have that, I say, okay, what do I need to, or which one of these can I make work so that if I throw in probably a negative sign because of the negative 24, so that I can get the multiplication and addition to go the way I want. And so if you come down to 3 and 8, you'll notice I put a negative on the 3 because negative 3 times 8 is negative 24, and negative 3 plus 8 is 5. And so you might have to play around with those pairs a little bit to find the pair that will work, okay, that will multiply and add like we want it to. But here's the thing, once we have that, I have x minus 3 and x plus 8. The shortcut is beautiful, and it's done. All right, we have one more example. This one's a little bit different, but it's still basically the same thing. Here's what we have. We have 10x squared minus 80x plus 120. And so the first thing I'd really like to point out is that we have a number here in front. And that's not what we said we were working with. Right? At the start of the section, we said these things look like x squared plus bx plus c. I have an extra number. So I'm going to remind you of something that I said in this video for section 5.1. Always look and see if you have a greatest common factor. Because if you do, it'll make your life easier and it will make your answer more correct. In this case, 10, 80, and 120 are all divisible by 10. So my greatest common factor is 10. So I divide all three parts by 10. I don't forget to put the 10 out front, right? My common factor always goes in front every single time. I don't forget to do that. But when I do the division, now I have x squared minus 8x plus 12. So I'm done with that 10. Notice it is part of my answer down here at the bottom. Please don't lose it. That happens a lot. People lose that greatest common factor that they found earlier in the problem. So don't lose that. But now I'm going to work with just my trinomial again. Here's my x squared minus 8x plus 12. I need a pair. It needs to multiply to be 12 and add up to, oops, sorry, negative 8. Oh boy, that was almost disastrous. There we go, negative 8. Right, because it is a negative. So, again, I listed all the pairs that multiply to be 12. So I have 1 and 12, 2 and 6, 3 and 4. You'll notice I circled the 2 and 6 and made them both negative because I can see that a negative times a negative would give me a positive 12, and that way when I add them together I also get negative 8. Okay, so be really careful picking your pairs. If you get the right pair, you're basically done because now we have x minus 2 and x minus 6. But if you get the wrong pair, you just get a wrong answer. So be careful with the pairs. I like to tell people, please check your pair. And when you think you have it, just check it and make sure that it works. It only takes a second, and then you know that you're right. Negative 2 times negative 6 is positive 12. Negative 2 plus negative 6 is negative 8. Take care of that, and you'll be all set. And good luck.